So for 7.3, now we're going to be working with what we call proportions. Has any of you ever heard of the phrase that something is proportional to the other? Yeah? Just using what we learned in the last lesson, what is proportional to 60 seconds? 1 minute. They're equal, right? So we need to first define the word proportion. So proportion is an equation, and what does equation mean? Equation means there's a equal sign. Okay, so an equation that states that two ratios are equivalent. Okay, what is another word for equivalent? Same or equal, right? We also need to know what is called cross products. We're going to be using cross products a lot for this. Taking a cross product means that we are going to multiply diagonally across the equal sign to check if the ratios are proportional. So we're going to multiply across the diagonals, and we should get two equal numbers. And that's going to tell us whether or not what we're looking at, the two ratios, are proportional. So example 1, we have two parts to this one. I'm giving you two ratios. 6 over 12 is equal to 12 over 24. And the second set is 5 over 7 equal to 10 over 15. And we're going to determine whether these are proportional. Okay, so the first one, 6 over 12 equal to 12 over 24. The question is, are they proportional, true or false? So what we're going to do is we're going to use cross products. We're going to multiply diagonally. So we're going to multiply 12 times 12. And we're going to multiply 6 times 24. Okay, let's do 12 times 12 first. What is 12 times 12? Very good, 144. Equals 6 times 24. What does that give me? Let's do it off to this side just in case. 24 times 6. 6 times 4 gives me 24. 6 times 2 gives me 12, plus 2 is 14, so I get 144. 144 is equal to 144. Is that a true statement or a false statement? That is a true statement. So that tells me that these two ratios are proportional. So it is true. Okay? Yes. Okay? So let's check the second one, part B. I'm telling you that 5 over 7 is equal to 10 over 15. But we need to use cross products to check first to see if they're proportional. So I'm going to multiply 7 times 10. And I'm going to multiply 5 times 15. Let's do 7 times 10 first. What does that give me? 70. Equals 5 times 15. Okay, 15 times 5. 5 times 5 gives me 25. 5 times 1 gives me 5, plus 2 is 75. Is that a true statement? No. So these two ratios, are they proportional? No. So our answer is false. So proportional just means that we're given two fractions and that they are equal to each other. That's all that it means. Okay, we use cross products so that we can check quickly whether or not they are proportional instead of having to reduce all of them. Okay, one note that I want you to make sure that we know. We can only use cross products when there is an equal sign. So will you please under that on your definition of cross products? We can only use cross products when there is an equal sign. If we are multiplying fractions, we just multiply straight across like we've always done. Okay, this rule does not change anything. Got it? Okay. Example 2. Word problem. Okay, so example 2, we're working with bubbles. A bubble solution can be made with a ratio of 1 part detergent to 8 parts water. Would a mixture of 56 ounces of water and 8 ounces of detergent represent the same ratio? Alright, so the whole problem starts with them telling us how we can set up our proportions. Okay, so it says that a bubble solution can be made with a ratio of 1 part detergent to 8 parts water. So how do I want to set up that ratio? What's going to go on top, the detergent or the water? Detergent. So let's put detergent on top. So I'm going to write, because our units are what is called parts, which means that we can do ounces, we can do pounds, we can do liters, it doesn't matter. I'm just going to write 1 on top. I'm not going to write parts. Okay? Or actually, how about we write 1 detergent so we know what we're talking about. So we're dealing with 1 detergent over how much water? We have 8 parts of water for every 1 part of detergent. So we're going to put 8 water on the bottom. So I'm going to write H2O. Okay? And I want to know if a mixture of 56 ounces of water and 8 ounces of detergent will give me this same ratio. So that's going to be equal to, what's on top, detergent or water? Detergent is on water. So even though 56 ounces is first in the sentence, we have to look at what we're talking about. So in this case, it is detergent. So we have 8 detergent ounces so we have 8 ounces of detergent on top, and how many ounces of water? Good, 56. So we're going to put 56 ounces water on the bottom. Okay, so I have 2 proportions here. Both of them have detergent on top and water on bottom, which is what we want. Okay, now we're going to do the exact same thing we just did. So we want to see if they're proportional. So let's multiply. I'm going to do cross products. 8 times 8 gives me 56. 8 times 8? No. 64. Equals 1 times 56. 56. Is this a true statement? No. So would this mixture represent the same ratio? No. So we just have to write no. And that's our answer. Okay, so example 3. Here's our problem. For most people, the ratio of the length of their head to their total height is 1 to 7. So here's the ratio. They give it to us, 1 to 7. If a person is 56 inches tall, what would the length of their head be? Okay, first of all, how many of you have seen a proportion written in this way before? Okay, we can also write fractions with colons like this, but we can rewrite it as a fraction. The first number is going to go on top, and the second number is going to go on bottom. So the first thing that I want to do is let's rewrite 1 to 7 as a fraction. Okay, so we're going to put our fraction bar. 1 goes on top, and 7 goes on bottom. Okay. Now it is telling us the length of their head to their total height. So the 1 is talking about their head because that's what comes first in the sentence. So this is talking about your head. So let's label 1 head just so that we know which one's which. And 7 is total height. So we're just going to write total. Okay. So we can read it from left to right still. Their head, that's the top or the first number, 1. Total height is the bottom or the second number. Okay? Now, they tell us if a person is 56 inches tall, what should the length of their head be? So they give us 56 inches tall. Would that go in the numerator on top or the denominator on bottom? Denominator on bottom. So we have 56 inches tall. So let's put 56 inches here. Do we know what the length of their head is? No, it's going to be a variable. What variable do you want it to be? H? H for head? Okay. So this time, we have two proportions, and we want to make sure that they are equal. So we want to know that if I am 56 inches tall total, and I want to keep this proportion, what should the length of my head be? So, H, we need to solve for H. So we're going to use cross products again. So let's multiply. 7 times H gives me 7H equals 1 times 56? 56. Okay, so now we have a one-step equation. 7H equals 56. What am I going to do? Divide by 7. So we get H equals 8. 8 what? Inches. Okay. Alright, so for example 4, we have a 12-pound weight is positioned 8 inches from a fulcrum, which is like those scales that you use in science, the balances. At what distance from the fulcrum must an 18-pound weight be positioned to keep the scale balanced? So we first need to write this first piece of information as a ratio. Okay, what do you guys want to put on top? It really doesn't matter. Do you want to put the weight or the inches? The inches? Okay, so we're going to put 8 inches on top, which means what goes on the bottom? The weight, 12 pounds. Actually. Okay, so our ratio is 8 inches for 12 pounds equals. Okay, what information do they give us? We know that we want to use an 18-pound weight. So in our second ratio, is that going to go in the numerator or the denominator? The weight. What is it on the other one? Top or bottom? The weight goes on the bottom. So we're going to put 18 pounds on the bottom of the second. And we still need to know the distance for this 18-pound weight. So we have to pick a variable. What variable? How about D? Okay. So the first ratio is the first piece of information they give us. We know that 12 pounds is 8 inches from the fulcrum. And then we also know the second piece of information that we have an 18-pound weight. But we want to know what the distance has to be. So what am I going to use to solve this? I'm going to use my cross. What? What's it called when I multiply cross? Cross products. Thank you. So 12 times D gives me 12D. And 8 times 18, that gives me, let's see, 18 times 8, 64. 8 plus 6 is 144. And I still have not solved for D, so what do I need to do? 12D equals 144, so I divide both sides by 12. And I get D equals 144 divided by 12? 12 what? Inches. If you're started and want to keep going, keep going. Okay. Jaren is downloading a file. The size of the file is 3,200 kilobytes. It takes 3 minutes to download the first 1,200 kilobytes of the file. If the file continues going at the same rate, how many more minutes will it take to finish downloading? So we first have to set up a ratio for the rate that it's currently going. So any ideas? What's going to go on top? What do you guys want to put on top? The kilobytes or the minutes? Kilobytes? Okay, let's do kilobytes for the top. What's going to go on top here of our first ratio? 1,200, because that's how much we know how long it's taken. So we're going to put 1,200 kilobytes on top. How long did it take to do 1,200 kilobytes? 3 minutes. Okay. It took us 3 minutes to do the 1,200 kilobytes. Okay. If the file continues downloading at the same rate, how many more minutes will it take to finish downloading? So we're not looking at how many total minutes, we're looking at how many more. So question, are we going to use 3,200 kilobytes or are we going to use a different number? We could actually do it 2 ways. I would suggest that we use a different number. Let's think about it. I have 3,200 total. Okay. I've already used 1,200 of them. So how many do I have left? 2,000. The only reason why I do this is because we're looking for how many minutes are left. So in order to look at how many more minutes or how many minutes we have left, we need to look at how many kilobytes we have left. If we do the total number of kilobytes, it would give us the total amount of minutes. And then we'd have to subtract those. Does that make sense? Okay, so it's a little bit easier if we just look at how many kilobytes we have left from the beginning. Okay, and then do we know how many minutes are left? No, we don't know yet. That's what we're trying to find. So let's use t for time here. That's our variable. Okay, so to solve, what do I need to do? I need to use cross products. So we have 3 times 2,000. What does that give me? That gives me 6,000 equals 1,200 times t gives me 1,200 t. And now what do I need to do? Any ideas? I need to divide by 1,200. All of those cancel, all of those cancel. And we are going to get t equals. Okay, I'm dividing 6,000 by 1,200. Is there a shortcut that we can do so we don't have to work with those big numbers? We can take away the zeros. Now, we can't take away all the zeros on 6,000, correct? Okay, because we have zeros here and zeros here. So we have to keep one of the zeros. So we're really just looking at 60 divided by 12. How many times does 12 go into 60? 5 times, and that gives us 60, correct? So we have t equals 5 minutes left. So to finish downloading the last 2,000 kilobytes, it's going to take us 5 minutes. So how many minutes total did it take? 8. So long. Okay, example 6. I have D dollars for every 12 hours equal to $96 for every 8 hours. So I want to know how many dollars I would make in 12 hours. Okay, so what am I going to use here? Cross products. So we have 12 times 96. So let's do it. 96 times 12. Okay, 2 times 6 gives me 12. Carry the 1. 2 times 9 gives me 18 plus 1 is 19. We skip 1. 1 times 6 gives me 6. And 1 times 9 gives me 9. I add those together. This is 2 plus nothing, so it's just 2. 9 plus 6 gives me 15. Carry the 1. 1 plus 9 gives me 10, plus 1 gives me 11. So I have 1,152 equal to D times 8 gives me 8D. Okay, now what do I do? Divide by 8. So those cancel, and I get D equals, let's do it off to the side. 8 goes into 1,152. 8 goes into 1 how many times? 0, so we skip it. 8 goes into 11. Twice. No, not 2. Once. 8. 11 minus 8 is 3. Bring down the 5. 8 goes into 35. 4 times. And 8 times 4 gives me 32. 35 minus 32 is 3. Bring down the 2. 8 goes into 32. 4 times. With a remainder of 0. So D equals 144 what? Dollars.